Alright, so we have another partial fraction that we want to set up our minus 19x squared plus 50x minus 25 over x squared times 3x minus 5. So we want to set up our denominators. The x squared we need to separate. So we're going to have a over x and then b over x squared. So one will be x, one will be x squared, and then our c will be that leftover piece, the 3x minus 5. So from here, we're going to clear our fractions, meaning we're going to multiply everything by the least common denominator. So, of course, this side, everything goes away. This side, we need to multiply by what's missing. So the least common denominator is x squared times 3x minus 5. So we're missing 1x and we're missing 3x minus 5. Plus the b already has an x squared, but it needs a 3x minus 5. And then plus c is missing an x squared. So that's what's called clearing the fractions. I mean, basically, we're multiplying every single thing by the least common denominator. All right, and so now from here, let's multiply this side out over here. So I'm going to have ax times 3x, which is going to give me 3ax squared, minus 5ax, so I'm just distributing, plus, let's distribute this, 3bx minus 5b, and then plus my cx squared. Okay, and now we're going to kind of group some things, so I'm going to look and see that everything that has a squared, 3a plus c has x squared. And then plus, I'm going to look at everything that has an x. So negative 5a plus 3b. And then finally, the leftover, which is minus 5b. So all I did was group things together based off of the exponents. So from here, I set each one of these exponents equal to the coefficient on their particular exponent. So I set 3a plus c up there at the top equals negative 19. Here the x is a 50. So I set negative 5a plus 3b equals 50. And then finally the last one is based on that negative 25. Minus 5b equals negative 25. And from here, I want to solve for a, b, and c. Well, we can see b's pretty easy to solve for. I can divide both sides by negative 5, get b equals 5. Now that I know what b equals, I can actually solve this for a, because I'm going to have negative 5a plus 3b, which is 5, equals 50. So I'll have negative 5a, 50 minus 15, 35. 35 divided by negative 5. A will equal negative 7. And then finally up here, I can solve for c, because then I'm going to have 3 times a, which a is negative 7, plus c equals negative 19. So I'm going to get negative 19. I have negative 21, so I move to the other side. Negative 19 plus 21, I get c equals 2. So this gives me all of my values that I need, meaning c equals 2, a equals negative 7, and b equals 5. And so what I do is I just go back and I plug them into this piece. And so I write my integral, my a, which is negative 7 over x, that piece, plus my b, which is 5 over x squared, that piece, plus c, which is 2 over 3x minus 5, that piece dx. And now that I have my partial fractions, I can actually integrate. Remember, the 1 over x is ln of x, so minus 7 ln. Typically you write it as an absolute value. This piece right here you would write as 5 to the x to the negative 2. So I can see when I add 1, I'm going to end up with minus 5 over x. So I'm just taking the antiderivative. And then plus 2 ln of 3x minus 5 plus c. And I am done.